Okay, so on to our next principle, the L of solid. This stands for the Liskov substitution principle. This is a principle that was first introduced in the late 80s by someone called Barbara Liskov when talking about data abstraction and hierarchy. Now, what this principle says is that if we have two classes, A and B, and A is a subtype of B, then objects of type B may be replaced with objects of type A, so we can replace any use of our supertype with an instance of our subtype without altering any of the properties of the program. So what it says is semantically we should be able to replace any instance of our superclass with an instance of our subclass, and it's not going to change the behaviour in any way whatsoever. And we'll look at an example of something that violates this principle now. So we'll look at a fairly typical example of a violation of this Liskov substitution principle now. So here we've got two classes, sticking with the shapes again. We've got a rectangle class, has area and accesses to change the width and the height of that rectangle. And we've said, well, rectangles are a base class for our square class. So we're going to reuse the area method here, and we're going to override set width and set height on the square, but to enforce the constraint of what a square is, i.e. when you set either the width or the height, it will set the other property to match that same value. Now, that might seem reasonable, but it violates this principle. So the Liskov substitution principle said that we should be able to replace any code that uses our supertype, our base class, a rectangle in this case, with an instance of the square class, and it will remain functionally correct. But that's not actually going to be true, because whilst square and rectangle do behave in similar ways, there's some degree of overlap there. You can't treat a square the same way as a rectangle. So you may have some application code that uses the rectangle, it changes just the width, expecting the area to be a certain value, but with the square, because setting the width is also going to change the height of that shape, but the area is going to be completely different to the area that it would have been had it been treated correctly as a rectangle. So you violated the semantics of what a rectangle is there by introducing your square class as a subclass of rectangle. Rectangle semantically is something which you can independently control those two sizes, the width and the height on.